Hello everybody, this is Zanand Patil. Welcome to my channel GK Science Academy. This is the second part of previous year solved All India Institute of Medical Science questions of the chapter Units and Measurements. Okay, please keep watching the videos, like the videos and share the videos. So don't waste the time. So let us start with the solutions of the next questions. So the question is question number 6. The magnetic movement has a dimension of. So this question was asked in All India Institute of Medical Science entrance examination 2006. So they have given four options. We will solve the question, that is magnetic moment M is equal to current into area. So if you want the formula, you can check the second PUC or NCERT 12th class physics 4th chapter moving charges and magnetism. Okay, so if you see the options, they have taken the dimensions L, T, A. L is the dimension of the length, T is the dimension of the time, and A is the dimension of the current. Okay, so here we will directly take the dimension of current as A into, here A is there, so that is area. So area is equal to length into breadth. So the dimension L into L, both length as well as the breadth has the dimensions length, so that becomes L square. Okay, that is L square. So this is A. Okay, then this becomes L square into A. So this is the final answer. We will match with which option? So the option is L raised to 1, A raised to 1 doesn't match. Option B, L square A raised to 1. So that's why the option B matches with the answer. So that's why the option B is the correct answer for this question. Okay. So the next question is question number 7. What is the dimension of impedance? So this question was asked in All India Institute of Entrance, sorry, All India Institute of Medical Science 2007. So they have given four options. So you have to observe one thing, that in each option they have mentioned the dimension I. So don't worry, that is nothing but the dimension of the electric current. So that is I. And we will start with the actual solution. So that is impedance. So impedance is analogous to resistance. So resistance is used in a DC circuit. Same impedance is used in a AC circuits. Okay, so that's why both resistance and impedance are analogous to each other or same. Okay, so that's why impedance has the same formula as the resistance. So that is potential difference or voltage divided by electric current. Okay, okay, we will solve impedance is equal to, so potential difference or voltage, that is nothing but the work done divided by charge divided by electric current. So that becomes W divided by Q into I. Okay, so make this separate part. Then impedance, that becomes W, that is the work done. So okay, work done having the dimension M L square T raised to minus 2 divided by, so Q is there, that is nothing but the charge having the dimension I into T. Okay, into, so that is the dimension of the electric current, so that is taken as a I. So simplify this, that what happens, M L square, so don't worry about the numerator, so just simplify the denominator. So I is there, so that is I square into T. Okay, so just take this I and T to the numerator, then what happens, M L square T raised to minus 2 into I to the minus power minus 2 into T to the power minus 1. Okay, the final equation, so that becomes impedance is equal to only one m is there, so that is m to the power 1. Only L is there, so that is L to the power 2. T to the power minus 2, T to the power minus 1 is there, so that become minus 2 plus of minus 1, that becomes T to the power minus 3 into the I to the power minus 2. Okay, so this is the final answer. Check which option matches with this: m to the power 1, L to the power 2, T to the power minus 3, I to the power minus 2. Okay, option 1, so that is option A, m to the power 1, L to the power 2, T to the power minus 3, I to the power minus 2. Okay, the option A matches with this answer, so that's why the option A is the correct answer for this question. Next question is question number 8. The dimension formula for torque is, so this question was asked in All India Institute of Medical Science Entrance Examination 2011. So this is again a very easy question. So if you know the equation for the torque, you can directly solve. Okay, so we'll solve the question. So solution, so torque, so that is tau is equal to force into radius or distance. So force having the dimension formula, I am going to directly enter the dimension formula for each quantities: mlt to the power minus 2, and r is there, so that is having the dimension formula L. Okay, simplify, only one m is there, so that is m to the power 1, L to the power 1, L to the power 1 plus 1, 2, so that is L to the power 2. Here t to the power minus 2. Okay, only one t is there, so that is t to the power minus 2. So this is the dimension formula for the torque. Okay, and now verify which option matches with this: m to the power 1, L to the power 2, t to the power minus 2. Okay, okay, option A, that is having the same dimension formula, m to the power 1, L to the power 2, t to the power minus 2. So that's why the option A is the correct option for this question. So the next question is question number 9. Dimensions of coefficient of viscosity is. So this question was asked in All India Institute of Medical Science Entrance Examination 2010. So they have given four options. We directly start the solution. Coefficient of viscosity, so that is eta is equal to force divided by area into velocity gradient. Okay, simply we have to substitute dimensions of each quantities. Okay, I will write dimensions. Force having the dimension m l t raised to minus 2. Area, so that is length into breadth, length into length, so that is having L square. Okay, then here dv by dx is there, so that is nothing but the velocity gradient. Okay, so in numerator velocity is here, that is lt raised to minus 1 divided by x is nothing but the displacement or distance, so that is taken as L. Okay, so L cancel each other, so that's why remaining is t raised to minus 1, so that is the dimension of velocity gradient. So substitute all quantities in the equation. Eta is equal to, that is coefficient of viscosity, F, that is m L t raised to minus 2 divided by area, that is L square, into velocity gradient having the dimension t raised to minus 1. If these two quantities go to the numerator, that becomes m L t raised to minus 2 into L to the power minus 2, because this 2 goes to numerator, so that becomes L to the power minus 2 and t to the power plus 1. Okay, simplify, we will get direct answer. Only one m is there, so direct is m to the power 1, L to the power 1, L to the power minus 2 is there, 1 minus 2, that is minus 1. t to the power minus 2 plus of t to the power plus 1 is there, so that becomes minus 2 plus 1, so that becomes t to the power minus 1. So this is the dimension formula of the coefficient of viscosity. We will search which option matches this. M to the power 1, L to the power minus 1, T to the power minus 1. Okay, option S. Option D, that is m to the power 1, L to the power minus 1, T to the power minus 1. So this option D matches with the answer. So that's why the option D is the correct answer for this. That is the option D having the dimension formula for the coefficient of viscosity. So the next question is question number 10. Which of the following pair of the quantities do not have the same dimensions? So this question was asked in All India Institute of Medical Science Entrance Examination 2011. So this is a very easy question, because in each option they have given two physical quantities. So out of four option, one option having the two physical quantity, both are having the different dimensions, so that we have to find. So if you see the four options, I can directly give the answer. So that is option C, because that is having the light year as well as time period. So light year is used in astrophysics, that is used to measure the large distance. For example, the distance between Earth and Sun, or any distance between Earth and any star, like that. And time period, so that is purely time, so that is having the dimension time. So that's why light year has the dimension distance, and the time period has having the dimension time. So that's why both are having the different dimension. So I can directly mark the option C as a correct answer, because both are having the different dimensions.